Hi everyone, welcome to Java Techie. Have you ever faced a situation where you need to integrate an incompatible service into your existing application? Or maybe you have integrated one services but later you need to plug in different services without modifying your existing code? How do you handle such kind of scenario? Well, that's exactly where the adapter design pattern comes in. So in today's video, we are going to simplify adapter design pattern with real-time use case. Okay, alright. So without any further delay, let's get started. So before we directly jump into the definition, let me give you a real life example so that it will be easy for you to think about this particular design pattern. I believe you all have wall socket at your home. That's where you charge your electronics devices. Now, can you plug your phone directly into this socket? The answer is no. You can't directly charge your phone in the wall socket because the socket provides 240 volt, but your phone only need 3 or 4 volt to charge. So here both source and target are incompatible. So how do we make them compatible now? Right? This is where the concept of an adapter comes into the picture, where this adapter converts 240 volt from the socket into the 3 or 6 volt your phone need. That is how our device is safe for charging, right? So here this adapter work as a bridge between two incompatible systems to make them work together. This is what is called adapter design pattern. Okay, hope this makes sense. If we all are in the same page, let's look at its official definition. The adapter design pattern is a structural design pattern used to allow two incompatible interfaces to work together. This pattern acts as a bridge between a client and a service, making them compatible without changing their existing code. It's very simple, right? The wall socket and your mobile both are incompatible, but the charger act as a adapter between these two incompatible system to make work together. Okay, so that is what all about the adapter design pattern. Now let's take it a step further and look at a real-time use case to understand when and why we need the adapter design pattern. That is what the important things to understand. So let me give you one real-time example. Let's consider you are working on a e-commerce project and your application is already integrated to two different payment gateway, Stripe and PayPal. Currently, your application only supports these two payment methods, but in future you want to enhance your application to support Razor Pay and Google Pay. Then what you need to do? You need to open your code base and start integrating this Razor Pay and Google Pay. So if you look at high level, your earlier code was like this. You have the support of this PayPal and Stripe payment gateway. But since you want to integrate other payment gateway, you need to open the code and you need to start configuring other payment gateway by calling their appropriate services. Now in this way, my application is tightly coupled with all the payment gateway. So if I want to integrate anything, then I need to touch my existing code and I need the proper testing and all the step I need, which doesn't look like a good approach, isn't it? Since each payment gateway has its own API, I will use an adapter to simplify the things and reduce tight coupling. This will allow you to add n number of payment gateway without changing your application code. So for that, what we can do, we'll create a component called payment adapter who will provide a unified method to work with all different payment gateway. Now my application will not directly connect with different payment gateway, rather it will connect to only the payment adapter, and this payment adapter will connect to all different payment gateway and make them compatible to work together for your system. So in this way, if in future I want to add a new payment gateway, then dynamically just I need to configure it in my adapter, or technically you can plug that new payment gateway into your payment adapter rather than touching your existing application code. Hope this use case is clear for you. So this payment adapter will work as a bridge between your application to different payment gateway. Okay, that is what the concept of adapter design pattern. So I believe this particular use case is clear for you. If yes, let's see it in action. So let me go to my IntelliJ IDEA. So to save our time, already I created a project to demonstrate this adapter design pattern, but I have not added any specific code for this adapter design pattern. This is just a simple code. Okay, let me walk you through the code as well. I have defined a controller class and I have defined one endpoint who will take the request, payment request for the transaction, and payment gateway, what user want to choose the gateway. Okay, so I will also have a service. In this service I do validate the gateway type. If user provided PayPal, then I will call PayPal specific payment gateway method. If user choose Stripe, then I will call the Stripe specific method. Okay, and you can observe here both PayPal service and Stripe service are two different services. You can go here. Now if you see here, this is what the two different service. This is what the use case, exact use case we understand, right? Now think that I want to integrate some different payment gateway to my application. Forget about adapter design pattern. Let's go with the basic step. Then we will come to the point why this adapter design pattern needs in software industry. Fine. Now think that I want to integrate the Google Pay service. So what I can do, like this PayPal service, I need to create another class. Okay. Then just define component. Since I am doing in the Spring, I am defining the annotation stereotype, but if you are doing it in a plain Java, that is also fine. You don't need to define any annotation, just directly create the object. So let me define the method. I'll just change it. This is just a dummy logic I have written here. Okay. Now, how can I configure this Google Pay service so that user can pass the gateway? Okay, I want to pay with the GPay, so that this specific service needs to call. So for that, you need to configure that in your payment service, which is the first layer to integrate to different payment gateway. So for that, just inject it. Fine. Now just add another statement saying that if the gateway type user selected, if it is a GPay, then call the Google Pay specific services. All good. Now let's test this application. Okay, let's test this process payment method. This is simple code, right? This is the plain Java code. So we just want to validate whether things is working or not. Then we'll go step by step and we'll implement the adapter design pattern. Let me run it. So it started on port 9090. Now let's go to the browser and hit this endpoint API/v1/payments by giving the gateway name, request body and gateway name. If I will give PayPal, it should call the PayPal service. If I will give Google Pay or Razorpay, it will call based on that particular service. Okay, so let's go to the Postman. Now I want to call the PayPal. This should be post, right? What payload we are sending here? Just let me check it. We are giving the amount and currency. Okay, that's fine. Just go to the Postman. Indian rupees. Okay, now let's send the request. We got some messages, but let's check in the log. It called the PayPal service. Okay, now let me give this one Google Pay. Let's see what it called. We got the result. We got the result from Google Pay. Okay, So it's simple statement. Whatever the input will give, based on that it will call the corresponding services. This looks little bit ugly, right? Being a developer, and if you know the oops concept, injecting directly the class and calling them doesn't looks good. So we'll break it further and we'll improve little bit better. Okay, so for that what you can do, you can create a class called, or you can just create an interface. Okay, so let me define something like, I'll create a new package, let's say processor, then I'll create payment processor. Okay, which will be an interface. Now here I will define a method, something like void make payment, then what is the amount you want to pay. Let's say I want to define the unified method. Based on this method, Stripe or PayPal or Google Pay or any other payment gateway, they will get the value and they will call their API. Okay, that's what I'm not trying to convince now. I have defined a interface. Now what I'll do, I'll create the implementation for each and every payment gateway. So how I can do that? Simple thing, right? I will just change it here only. In the services, I'll just ask PayPal service, hey, just implements it from payment processor. Fine, and make payment method, just override the method. Similarly, I will ask all the payment gateway implementation to inherit from this, so that I will provide a unified method. So go to the Stripe service, make payment, right, or process payment. What is the method name? Make payment. Similarly, do the same thing in Google Pay. Now we have three different implementation of this processor. Since this is the Spring Boot, you will find the ambiguity error if you are not using the qualifier, because a simple single interface having multiple implementation. So to make it simple, let's remove it for now. Okay, so just remove the component annotation from all the implementation class. Now go to the payment service. Here you no need to inject individual payment gateway implementation. Rather, you can directly play with the interface. That is the reason we have defined the interface, right? So you need to play with the runtime polymorphism. I could directly jump into the adapter design pattern code, but I am just going step by step to simplify the things and to give you the hints about importance of this adapter design pattern. Okay, now what I can do, I'll create a factory method who will give me the object of payment gateway, PayPal or Google Pay or Stripe, based on the user input. Okay, so I'll do something like this, private, who will give me the object of interface. Behind the scene, it will create the object of implementation class. Since this interface implemented to three different implementations, so I have just defined the interface as a return type. Okay, so get payment gateway instance or something like that, based on the gateway type. Okay, so I'll just use this switch case, or you can also go with the if else, that is fine. Now here what I want to return, I want to return the object of payment processor implementation. If it is a PayPal, then better I will define the variable. So if it is a PayPal, then give the object of PayPal service IMPL. Similarly, if it is a Stripe, just give the object of Stripe. Same for Google Pay. Then just simply return the processor. With the help of parent reference, we are creating the object of implementation or child. That is what called runtime polymorphism, right? That is what we are just doing as a factory method. Now, do I need to inject each and every gateway individually? No, right? So simply just do one thing. You also don't need this switch case. you just need to call this method get payment gateway instance by giving the gateway. Okay, it will give you the object of that. Just call the method make payment, give the amount payment request dot get amount. Okay, that's it. We simplify it to one line. Shall we test it whether it is working or not? Let me test it. Let's restart the server. So it started. Let me clear this. Go to the postman. Let me send the request. We got the result. Let's check in the output. We got the response from Google Pay. Now let me pass the Stripe. We are getting the correct result. So based on the gateway, we are creating the corresponding implementation object and we are redirecting our request to that. Okay, can you see this approach? So this approach will just add one layer abstraction for our previous approach. Okay, previous approach we are injecting each individual class. Now in this approach we are injecting a interface and based on input we are creating the object, which is kind of factory. Correct? Now again in this approach, in future if I want to use some phone pay service or Razor Pay service, what I need to do? I need to create a service class like this and I need to implement from payment processor. Then again I need to configure it in my service. If case equal to Razor Pay, then processor equal to new Razor Pay service. Like that I also need to create the object of that. Correct? Again the approach what we have implemented, it does not make any sense. Again if you see here, while adding the last payment gateway, we no need to do any code change. I want it to be dynamically configured to my adapter. How can I do that? It's very simple. Just go to the code. We'll use the factory and adapter design pattern combination. Okay, we'll not go with manual object creation. Rather, we will eliminate that and also will eliminate the switch statement. And we no need to take the headache of object creation. Let's make it dynamic by implementing the logic, by implementing the adapter design pattern. So let's try implementing that. For now let it be, I am not going to comment this for now. Let's implement the code, then we will format this. Okay, so here what I want to do, I want to create a map. I'll tell you why I need to create a map. Let's say final map. I want to keep a key as a your gateway of type string and value as the implementation of payment gateway, which is nothing, you can provide your interface name. So you can name it payment processor or something like that. So remove this for now. Now here simple thing, let me add a note. What I want to keep in a map, key as a let's say PayPal, then value should be its implementation class PayPal service. Okay, similarly key will be Google Pay, value will be its corresponding service, so that when user will give the gateway, I will come and search in the map based on the key, I will get the implementation class which is the value, then I can simply call the method, right? That's straightforward. Now let's initialize this particular map. So what I will do, I will just create a constructor. To initialize that I will just remove this because I will keep a list of payment processor, then I will iterate and I will get the class name. I will show you just a simple logic. Okay, so just take the list of payment. Now this is my interface and this interface has 3 implementation, right? So that is the reason I keep in a list so that I will iterate and I will get their class name. So just go to the services and for better visibility what you can do, right, you can change this class name to adapter. That make more sense. Okay, because we are discussing about the adapter design pattern, it's good to change the, instead of defining the service, I'll create another package called adapter. Just move these 3 class to adapter and then just rename this class name. Let's say I'll just refactor it, function shift F6 Simple. Now just close this here. Now here what you can do, just iterate this particular implementation. Okay, so it's simple, right? Payment processors dot stream dot collect, then collectors dot to map. So what should be your key? Key should be your gateway name and value should be your implementation name. Okay, so to get the key, what I'll do, I'll just use the lambda get class dot get simplified name or something, simple name, right? Yeah, get simple name, then value is nothing, function dot identity, just initialize this to the map, which is nothing here, payment processor map. This makes sense, right? Now this, what this map will contain, key is nothing here, processor get class dot get simple name, which is nothing here, whether it is PayPal adapter or Stripe adapter or Google Pay adapter, it will just keep your class name, and value is nothing, it's implementation class. Okay, that is what I have already added a note here, right? That's fine. Now let's use this. Let's, from this map, let's get the value and use it. Now just a one line change, let's remove this, we don't need this approach, so I'm not removing, just comment it for now. Fine, even I don't need this approach to invoke the implementation class. So what we need, we have the map, we know what gateway user is giving, and this gateway is nothing, key of your map. So just do map.get, pass the key, get the implementation and call that corresponding method. So it's simple, right? Payment processor map dot get, what will be your key name? Key name is something like this, right? Let me add it again. In this constructor we are defining the key, key is nothing, is this one, PayPal adapter will be your key, and value is nothing, dot class. Okay, so what object you need to get from the map? Gateway you are getting here, gateway which you will get as a only PayPal or Google Pay or Stripe. So just append the adapter. Now whatever the adapter gateway value you will pass, append the adapter, that is nothing, your simple name of your class which we kept in the map. Then based on that it will give you the implementation class. Just define the variable payment processor. Okay, now just call the payment processor dot make payment, give the amount which is nothing, you get it from your payment request. That's it. How simple is this? We no need to take the headache of object creation, we no need to take the headache of adding the switch or conditional statement, we no need to take the headache of hard coding the adapter or tight coupling the adapter to my actual code, right? So we have defined the adapter, this adapter you can see, right? PayPal adapter, Stripe adapter, all these three adapter being connected through this interface, and my service is connecting to this adapter through these services. Okay, now first let me run this, then we'll quickly configure another adapter and we'll see how much code we are going to change if we will configure the new payment gateway. Okay, so let's run it and we'll validate that. Then before I run, we'll do one thing, just define component in each and every adapter, because in previous code we are creating the object manually, right? So that is the reason I have removed the component. Now Spring will take care of it. Okay, this dependency injection concept, just define the component. All good. Now let's run it. So it started, just clear everything, go to the postman, I'll just call the Stripe. Okay, so make sure to pass the correct name. So whatever the name you will provide, it will just append the adapter that will be kept as part of your key. Okay, and based on that it will get the implementation class and will call the method. Let's run it, we'll see. We got the result, whether it called the endpoint or not. Let's check it. Yeah, it called the correct stripe. Now if you want to access the PayPal, give this as your gateway from the request. You got the result. Go and check in your console. Yeah, it's calling the appropriate method. Correct? That's great. This is the actual implementation of adapter design pattern. Now if you see, request comes to the controller, then from controller it will goes to the service. Now in service, I don't know how to communicate to the different payment gateway. Who is helping me to do that? My payment processor. My payment processor has three implementation: PayPal adapter, Stripe adapter and Google Pay adapter. Now from each adapter you call the actual API of that payment gateway. I have provided a unified method. From here, whatever the field or whatever the value you need to call the PayPal, just write the actual logic. Same for here. Okay. So this payment processor offers a unified method to make the payment gateway compatible with my payment service to all the implementation. These are my adapter, right? My adapter will connect to the actual gateway. Okay. So that is what the main purpose of using adapter design pattern. Now think I want to implement another adapter. Then let's see what all code changes I need to do. Do I need to change any business code, or do I just need to define the adapter? He will take care of integrating to that payment gateway. Let's see that. Okay. Let's say I want to integrate PhonePe. I'll just create a adapter. I no need to touch anything else. Just define here Java class, implement it from payment processor, provide the unified method, just add it. Now here add a statement. You can add a log statement or just define the sysout. Here you need to call actual PhonePe API. That's not your header, right? You have provided a method. From that method you call whatever the payment gateway you want to integrate to your application. This is just a adapter. This is just a plug which will help to make this payment gateway to compatible with your application. Okay. Now I just need to define this adapter. That's it. I no need to do anything. This will be automatically configured in my map. This payment processor map. Okay. Now if I'll pass this PhonePe, I should able to get the result from here. Just see what is the negligible changes I did here to just integrate another legacy service, or you can consider another external source. I have not changed a single line of code of my application. I have only added a new adapter. That's it. Let's run it again. So it started. Just go to the Postman. Just change your gateway, which is PhonePe, which is the new gateway you added. Just send the request. So get 500. What is the mistake? Okay, null pointer. Okay, so the mistake, Spring is unable to create the bean of it. So define the component, because we are not creating the object, right? The object will be created by Spring IOC. So define the stereotype annotation. All good. Go to the Postman, send the request. We got the result. Now let's see in the output. Payment processed via PhonePe. What is the minimum changes I did to just integrate another payment gateway? I just define an adapter. That adapter will take care of everything. Okay, that is what all about the adapter design pattern. Okay, so definitely you must have this kind of implementation in your existing project. Just check this out. This is quite interesting design pattern and it is being widely used in industry. So just give a try with different use case and do let me know in a comment section if you have any doubts. That's all about this particular video, guys. Thanks for watching this video. Meet you soon with a new concept.